How's the air coming?
Not quite enough. Pump a little faster, will you?
A little faster, Jack.
Hey, what's going on up there? Who's trying to smoke me out?
Move aft, Mike, and give him some air.
We cannot live without air. Air. Good old air. This diver knows that air is precious to him. He probably doesn't stop to figure why. We need the oxygen in the air to combine with fuel in our bodies to give us strength and warmth. In our bodies, this combining of oxygen with the food we eat is taking place every second of our lives. It is called oxidation. Burning is another common form of oxidation. Burning is a rapid combining of oxygen with fuel. Without oxygen, nothing can burn. If we cut down the supply of oxygen, the fire gets weaker, and when the oxygen is used up, the flame goes out. By covering the fuel with water or chemicals that keep air from getting in, we can cut off the supply of oxygen and put a fire out. But when a fire gets plenty of oxygen, it will use all the fuel it can get. The more air it gets, the faster a fire burns. So when we want hot fires that will get the maximum energy out of the fuel, we supply a lot of air, free air. Air is forced up through the flaming bed of coals in the modern locomotive. In many ocean-going ships, when extra power is needed, the entire boiler room is filled with air under pressure, causing a strong draft to rush through the fire, carrying an extra load of oxygen. Even steel will burn if it gets enough oxygen. If small shavings of steel are heated until they are red hot, then placed in pure oxygen, they will burst into flame. Steel, however, doesn't catch fire easily. Some things ignite more quickly, like excelsior. Or celluloid. One of the easiest things to ignite is gasoline. If we pour a few drops of it on a wad of cotton, it will evaporate. And the vapor will roll down to the lighted candle. That's why gasoline should never be brought indoors. Gasoline burns so fast that it seems to be an explosion. It is really just extremely rapid burning. Fortunately, we know how to control the burning of gasoline. And the best example of control is in the automobile engine. But liquid gasoline alone won't run an automobile engine. It has to be mixed with free air. This mixing is done on the same principle used in a garden spray gun. When we pump the gun, a rush of air picks up tiny drops of liquid and forces them out the nozzle in a spray or mist. In order to get a fine spray, the nozzle of the spray gun is small. In the automobile engine, this mixing of air and gasoline is done in the carburetor. It begins in a tunnel through which the air sweeps at a speed sometimes as high as 800 miles per hour. This whirlwind races past the mouth of a small tube. and carries the droplets of gasoline into the intake manifold and onto the engine. This funnel is called the Venturi tube. It controls the speed of the air. Air has to go faster to get through the small opening. As the air goes faster and faster, it breaks the gasoline into even smaller drops. Now we let in more air and further thin out the mixture until we get the correct proportion for power and economy. The up-to-date carburetor is a higher development. There are float chambers to regulate the fuel supply, different jets for various speeds, Venturi rings for better mixing, metering pins, throttles, needle valves and chokes for control and economy. All the features that engineers have designed with great care to make sure of economical results. But the principle is still the same. The carburetor has but one purpose, and that is to mix a little drop of gasoline with a great big bubble of free air. In a one-cylinder engine made for laboratory experiments, we can see through a quartz glass window the burning as it occurs like lightning. The development of these modern methods of mixing gasoline with air, together with the improvements made in gasoline pump, intake manifold, and cylinder head design, have resulted in increased mileage per gallon of gasoline. Let's prove it. Let's see just how much air is actually used in the modern automobile. We'll take all the air that goes into the carburetor from this big balloon and the gasoline from this tube. The balloon holds 15 cubic feet of air, and the tube contains only 3 tablespoonfuls of gasoline. Here's a race that's worth watching. A race to see how much gasoline we need while using enough air to run our car 1/4 of a mile. The last of the air, and the race is over. We've gone just exactly 1/4 of a mile. But look, we still have some of the gasoline. Less than 3 tablespoonfuls of gasoline to travel 1/4 of a mile. In fact, 1 tablespoonful of gasoline is mixed with about 43 gallons of air to make the fuel for the modern motor car. Progress, through constant improvement, has reduced fuel consumption importantly, taking advantage of every opportunity to burn less gasoline and use